Today we will start with the hot water calculation. Okay, so the first one will be electric water heater individual. Then the second one will be electric water heater centralized. Then gas water heater centralized. Solar water heater centralized. Then boiler water heater centralized. So these are the different type of water heater equipments. Okay, so basically you know that our requirement, right? In every any toilet or any of the kitchen areas, we require hot water, right? So how to get the hot water? By means of some equipment. Okay, so in that equipment, what are the different type of equipments we can able to get the water getting heated by electric water heater, or by gas, or by solar, or by boiler. Okay, so these are different types, right? Okay, if you go to ASHRAE standard, okay, here you can see that hot water demand per fixture for various type of buildings. Okay, so whenever you going to calculate the water heater, you are going to calculate the what is the capacity, like what is the heating capacity required, okay, for that particular water heater capacity, like for that particular capacity, like the total storage. Okay, so we are going to calculate the capacity for the water, how much we are going to store it. Okay, so here you can see the different category, right? For example, you can see the basin, then you can see the lavatory, then bathtub, dishwasher, food basin. Okay, there are different type of plumbing fixtures, right? Servicing, okay, shower. So these are the fixtures only required water heater, water heating, like heating water, right? Say for example, there is no WC here, there is no urinal here, because that doesn't require what heat water, hot water, right? So only which fixture is required hot water, only it is listed here. Okay, next one, you can see that each and different type of category. There is apartment house, or club, or gymnasium, or hospital, or hotel, or individual plant, industrial plant, or office buildings, private residence, or school, or YMCA hospital, hostel. Okay, so this is a different type of building and different type of fixtures. Okay, so now whenever you are working with a project, you have to correlate with which type of projects and what is the type of fixtures. Okay, then you have to select the amount. Okay, that is called liters of water per hour per fixture. So when I say that kitchen sink for hospital, I have to select 76 liter of water per fixture. So I will be consuming 76 liter of water per kitchen sink. Clear, right? Anyone have doubt to calculate the capacity? Okay, say for example, if I have a shower for hospital, okay, so I will be consuming 284 liter of water per shower. Okay, so this is as per ASHRAE standard, which you can see here. You can see that 2019 ASHRAE handbook application based on that. Okay, so here you can see all the category and all the type of buildings and all the type of plumbing fixtures. What is the amount will be consumed? So depends upon, based on that, our calculation sheet is prepared. So if I go to individual water heater, you can able to see the different type of fixtures here. Okay, and you can see the capacity, right? How much flow rate, okay, required, how much of capacity required, how much of uh, storage required. Okay, so you can see that this much of water, right? Kitchen sink, it is 10 gallon per hour. Okay, here it is in liter per hour, but I have my sheet is in gallon per hour. So just why I made two sheet, because you may work with two different units. Okay, or you can convert into gallon per hour to liter per hour. You can convert. Okay, so this value will be, say for example, I have a 2 gallon. Okay, if I go to my conversion, gallon to liter will be 3.785. Okay, so what I will do, I will just take this value, I will multiply by 3.785. So this will be 7.57, which may be close to this value, right? If you have apartment. Okay, if you have apartment or private residence, okay, the same value, right? So if I use the same thing to everywhere, I'll be getting the value capacity here, right? Okay, so this is in liter per hour. If I calculate my total demand, liter per hour, Then what I will do, I will multiply my total fixtures, then I can able to get the total liter per hour. Okay, say for example in one of the toilet, okay, I have a 4 lavatory. Okay, then I have a 2 sink. Okay, I will just simply enter the quantity, then I can able to get the total capacity required. Okay, say for example pantry sink, 2 numbers. Okay, if I calculate, I can able to get the total liters of water per hour fixtures. Anyone have doubt? Okay, then if I go to ASHRAE, then there is a demand factor and storage capacity factor. Okay, what is the demand for each building? What is the percentage of demand? 30 percentage, 30 percentage, 40 percentage, because I will not be using my hot water 100 percentage. I will be mixing with the cold water. So what is my hot water requirement based on the demand? It will be 30 percentage, 25 percentage, 30 percentage, depends upon the building. Okay, and how much I have to store? I have to store 1.25 times because I will be using, right, apartment. When I use the apartment, I will be using 1.25 percentage. If I have a club, I will be using 90.9 percentage. Okay, gymnasium 100 percentage, hospital 60 percentage, hotel 80 percentage. So this is the demand factor and storage factor. Aditya, you have any question?
No.
Simple, right? This is a simple table from the ASHRAE.
Right.
Okay, so you have a different category, different type of buildings. Then you have a different plumbing fixtures. Then there is a demand factor, how much demand you will be consumed. Okay, whether 30% or 40 percentage, or how much of hot water you will be consuming, because you will not consume 100 percentage of hot water, you will be mixing with the cold water. Okay, and storage factor, how much capacity I have to store it. If it is office building, I have to store 2 times because I have a repeatedly, I have my people will be using the hot water, right? But they will be using 30 percentage only. But how much? What is the storage factor required? 2 times, because they will be continuously, they will be using, because the people will be using continuously because the number of people are more in the office building. And if you talk about apartment houses, maybe I'll take shower, I take something, then that is why I have 1.25 percentage. Okay, if it is a gymnasium, I will be taking 100 percentage. Okay, and if it is a hospital, I will be taking only 60 percentage because I don't require hot water for hospital that much amount, because the people will be using only for wash basin, or for small amount of hot water only they will be utilizing, not for shower or not for large purpose, right? So that is the based on that ASHRAE, based on that research, they have made this guideline. Okay, so if you go to this particular chart, you can able to get the total, what is the capacity required, what is the possible maximum demand. Okay, and then demand factor depends upon the type of building. Okay, then the storage factor, then based on that you can able to calculate the total probable maximum demand in liter per hour. Okay, then if you convert, okay, if you convert this value, if I convert this value from probable maximum demand multiplied by storage factor, then I can able to get the calculated storage capacity in liter. Clear, right? So this is the my calculated storage capacity of my tank, 53.9. Clear, right? Okay, then I have to calculate my thermal power requirement. What is the thermal? What is the heat transfer equation? I can say that Q equal to M Cp delta T, right? So this is my equation. So what is M? It is nothing but volume into density, right? So this is the mass of material. Clear, right? So my material is water. So I'm going to calculate the volume of the liquid multiplied by density of the liquid. Okay. Then after that, specific heat of the liquid. which is water. Which is water. Okay. Then I will be calculating delta T. Okay. So delta T means temperature difference. Okay. So you can see that maximum temperature difference, maximum temperature for the water will be 60 degrees Celsius. So you can see here calculated as a final temperature of 60 degrees Celsius. So whenever you say 60 degrees Celsius, it will be considered as a hot water. Okay. Which is more than 45 degrees Celsius as a hot water. That is a star. If you go to IPC standard, they have given that particular value. Okay. When you have to consider as a hot water. Below that, it will be normal water. Okay, so here it will be hot water considered as a 60 degrees Celsius as per ASHRAE. Okay, so what is the water temperature, incoming temperature during my summer or during my winter? What is the lowest temperature I can able to enter my temperature here? Whether it is 5 degree or it is 10 degree, whatever the water temperature I can able to mention here. Okay, so I can able to calculate the delta T, right? So what is the delta T? 50 degrees Celsius. Clear? And what is the specific heat of liquid, which is water? I can able to calculate, which is 4.186. Okay. And what is the volume of the water? I can able to calculate here, which is 53.9 liter. Okay, that is the volume of the water, right? Then multiply by density. Density is nothing but 1000 kg per meter cube. So if I calculate everything, okay, so you can calculate here what is that Z4. Z4 is the water density, right? Density here. Okay, multiply by Z5. Z5 will be the specific heat. Multiply by delta T. Z7 minus Z6. Okay, multiply by Q34, which is capacity, which is my capacity here, probable maximum demand, because this is the amount required. Okay, 43.1, right? Multiply by, actually they have given 3.75 because they are going to convert from this 3.785 is not required because we are not going to convert from gallon to liter. We already converted from directly to liter. Okay, so if I see here, this is my thermal power requirement. Okay, so here you can understand how to calculate the capacity of the storage tank, how to calculate the thermal power required, like how much, what is the heat capacity by using that equations.